have this situation where you go, say 2.0 meters at 70 degrees. Then you turn and go west for 5 meters. Find displacement. So it always helps to draw the situation. So we'll start with that. So you go 2 meters at 70 degrees. So that's about right here. So the angle you want to make would always be if you were to have a horizontal line on the x-axis. And that would be your angle, 70 degrees, from the x-axis to the green vector. So you go 2 meters, and it says then you turn west. So west, you would draw basically as a straight horizontal line. This is west, right? You're going to the right. You're going for 5 meters, so you want to make that about more than double the length of the green line. What angle would west be?
Wouldn't the other one be west?
Oh, I'm sorry. Yeah, that's east. Sorry about that.
Parallel?
Yeah. Wait, what do you mean by parallel?
The lines.
Oh, yeah, the black line and the purple line, yes, they would be parallel, yes.
If they're parallel, then if one angle is 70, the other one is 90, and then alternate interior angles congruency.
That's
Means
right.
that the interior angle.
Sorry, I got me east and west mixed up, but yes, that
Then
left
the
way is west, right way is
included
east.
angle is 70 degrees.
Yeah, that's true. So we can think of it as, 70 and then 110, and then like you said, the other angle would be, that's right. So if you have 2 parallel lines, which you do, then yes, you would know these angles as well. It's good.
Did they specify that it was parallel?
Well, you can draw it. I mean, you don't have to specify. This black line I just drew in. It's so you can make that line. Because this 70 degrees is based off that parallel line. It's based off this black line. Okay, so what we're asking for is displacement. Displacement would be, where did you start? You started right here. Where did you end? Right here. And so what they really want is the length of this red line. And not just the length, but the direction. They want to know the angle of that line. So we talked about law of cosines yesterday. But in this situation, when it's this kind of problem, it's better to do a different method. So I'm going to show you a different way to solve this in the law of cosines. Many times you can use law of cosines, but sometimes you can't, or it's not as easy. In this situation, it's easier to use a different method. So the way to solve this, I think that makes the most sense, would be to use vector resolution. Which basically just means splitting vectors into x and y components. Which might sound difficult, it's really not. All you're doing is multiplying it by sine and cosine. So what we need to do is take the vector length, which 2 meters is the green vector length, multiply it by cosine of 70, that gives you your x, and then 2 times sine of 70 and to get your y. Same thing for this one. You would take 5 meters, multiply it by the angle. What would be the angle of the purple line?
The angle, which one?
So the purple line right here, relative, which way did you turn?
Relative to the green or the red?
So you want to think of it as relative to this horizontal line. You want to draw on the horizontal line and say relative to the positive x-axis, what angle are these vectors? So this one is 70 degrees relative to here. What would this be?
180.
That's right. So we would use 180 degrees. So west, 180 degrees. East, if we had a vector going the way I drew it before, that'd be 0 degrees. Oh, you know what, that's I have my earpods on the wrong thing. Well, I guess it's okay now. I know Brooklyn's gonna be hearing this or not, but we'll see. Try to speak up louder. Okay, so 180 degrees would be that right there. See, I wear my AirPods so people on Zoom can hear it better. That's on my phone. Just hear my phone go off. So that's not gonna help anything. I'll fix it later. Okay, so what we would need to do is do the magnitude times sine and cosine of each vector. So call this vector A, call this vector B. So we would take 2 meters times vector A's angle, cosine of 70 degrees, that would give you A of X. And then you would find A of Y by taking 2 meters and multiplying it times sine of 70 degrees. So that's how you do vector resolution. That's how you split into X and Y components. So when you multiply 2 meters times cosine of 70, that's how far horizontally you went. So let's go and do this really fast.
Oh, why did you use cosine for X and sine for Y?
Oh, so yesterday we talked this a little bit, but basically we use the XY coordinate plane where we define cosine as tied to the X and set.
Okay.
Right, good. If you were to have a vector on the x-axis, and you were to use a triangle, and this is theta right here, and you were to say cosine of theta is defined as this side over the hypotenuse, right? So if A is the hypotenuse, that's the vector, X is this, cosine is defined as X over A, adjacent over hypotenuse. Now we can solve for X and we can move A over here. So A times cosine of theta equals X. And so that's why we can do that. And then same thing for sine. Sine is opposite over hypotenuse. So sine would be tied to the Y.
I know a funny way to remember that.
Oh yeah?
You write like COS, like you have cosine and then sine. You put them in parentheses and you put a comma between them.
So you say you do COS.
And then sine, and then comma between them, parentheses on the outside. And so that's how you remember it, that X
Oh,
is
okay,
cosine.
X and
It's
Y.
cosine.
Mhm. Oh, that works. That's good. So let's go through these really fast. Does anybody have these in a calculator? 2 times cosine of 70 and sine of 70?
The first one, 0.68.
0.68. Okay, so that tells you, yeah, if you were to make this into a triangle right here, that's how far this way, how far horizontally you went. So A of X would be your displacement horizontally. And then when you're finding A of Y, for the next thing we're doing, that's how far upwards you went. So
That's 1.8.
1.8. So basically what that tells you is you went over 0.68 meters and you went up 1.8 meters. So when you walk 2 meters at an angle of 70 degrees, that's your displacement horizontally and vertically. And then we're going to do the same thing for the purple vector. So what we'll do is we'll take A of X and A of Y. So A of X would equal the vector's magnitude, 5 meters, times cosine of its angle. We said it's 180. It's defined as the positive x-axis. And then A of Y is equal to 5 meters times sine of 180. What do we get for those?
The first one is -5.
Good.
The second one's 0.
Right, so and that makes sense, right? I mean, if you think about XY coordinate plane, you know, you're going to the left, leftward is negative, right? You're going 5 meters to the left, we define that as negative, and they're not going upward or downward at all, right? And so you don't have any vertical displacement. And so that makes sense based on what we're seeing on here. You with me so far on this?
Well, what does it say? The
Cosine of 180 equals -5. And then 5 times sine of 180 gives you 0.
Are there any,
Sorry?
like, functions we should memorize? Because I know that like for geometry, you memorize like the special right triangles. Are there any like really commonly used sine and cosine values?
No, well, I mean, not in this class. In pre-calc, yeah, you're going to memorize some, like, you know, 30, 60, 90, 45 are pretty common ones for sine and cosine. But for physics, there aren't any that are commonly used, so it wouldn't really help you memorize anything in this class. You just always need a calculator.
Yeah.
But in math, yeah, you will want to memorize a lot of different ones. Whenever you have to go math, you can just go. I don't know exactly when you have to go, but whenever you need to. Okay, so what we're gonna do now, so this red line is C. So we're gonna find C of X and C of Y. What we wanna do is find out how far did you go horizontally, which would be C of X, and then how far did you go upward, C of Y, and that will give us our displacement. So we want to find this magenta line, this purple line. So that would give you C of X and C of Y. Okay, how do we do that? Well, all we need to do is just add the X values and the Y values together. So to find C of Y, you just take A of Y right here plus, this should be B, I'm sorry, this right here, that's the B vector. Sorry about that. Yeah, we label this as A and that's B, so that should be B of X and B of Y. This one right here. A of Y plus B of Y. And then same thing for C of X. You just do A of X plus B of X. So what do we have? We have A of Y is 1.8, B of Y is 0.
What line is B of X and B of Y?
Oh, so for B of Y, it's just 0, right? You're not going anywhere up or down with B, right? So B is the purple line right here. And and B of Y would be how far upward or downward you went. Well, if you're going this way, you're not going upward or downward, right?
Yeah.
And so B of Y is just 0, so we can't draw that one.
Oh, okay.
And then B of X, well, that's just this line, right? Because that you went horizontally.
Oh, okay.
Okay, so C of Y is A of Y, which is 1.8, plus B of Y, which is 0. So C of Y just equals 1.8. So we know that you went up 1.8 meters during the journey. What about C of X? Well, you just do A of X plus B of X. A of X was 0.68. B of X, -5. Add those together. What does that give you? What's
-4.22.
-4.22? Sorry, what?
32.
32. Okay, so your net effect, you went, so C of X is equal to -4.32. Okay, so now we know your X and your Y displacement, but what do we want to find? We wanted to find the red line. So that's the hypotenuse. Now, X and Y make a right angle. You know, this is the X and the Y axis, which are right here. So this is 90 degrees. So 90-degree triangle, we can use Pythagorean theorem to find the hypotenuse. You with me so far on this? Okay, so we can just do 1.8 squared plus 4.32 squared to get the hypotenuse. So what do we get for this when we do 1.8 squared plus 4.3 squared? Let me know when you get that.
21.9.
21.9. So we get c squared equals 21.9. Square root both sides. And what do we get when we square root it? Do we have that? Okay.
4.67.
4.67. Okay, so the hypotenuse, 4.67. So that's part of the answer. We're trying to find displacement, right? Displacement is how far did you travel? Well, we got how far, it's 4.67, and also what angle did you travel at? So what we want to do is find the angle from this black line to the red line. And that's what we want to try to find. From the black line to the red line. Well, the simplest way to do that would be to use tangent. Tangent is equal to y over x. And so we can use inverse tangent of y over x to get the angle right here. So we can use inverse tangent of y over x to get the angle. And once we know this angle right here, subtract 180, we can get the angle we really want, which would be that part right there. So what do we get? We get y is 1.8, x 4.32. So you with me on this part?
Wait, what is that for?
Oh, inverse tangent gives you the angle of theta right here.
So you have to find the hypotenuse and the angle?
Yes, yeah, they ask for displacement. Displacement, you have to find distance and direction.
Oh,
Why is it not negative 4.22?
You could do that, although at this point, if you draw the diagram, you know what you're trying to find, you don't need to. And so it's better to just draw the diagram and then add angles if you need to, or subtract angles as you need to. What we're going to do with this one is we're going to subtract 180 from that answer to get the real angle. If you weren't doing that, you'd want to put negative in here. That gets complex. I don't want to get into that. So it's better to just do it like this, where you draw the diagram, you know the angle that you're looking at, and subtracting as you need to get the real angle. So in this case, just always use positive values, and you can subtract as you need to. So inverse tangent of this, what does that equal when we do that?
22.61.
22.61. And with sig figs, we only have 2 there, so we do 23 degrees. Okay, so that gives you this angle right here, 23 degrees. But that's not the angle that we actually want, because we want to define angles as from the x-axis over. So the real angle that we want would be 180 minus 23. So if we do 180 minus 23, what does that equal? We have that? Yeah, well,
157.
157. So the angle of that, your displacement is 157 degrees. So our displacement answer, we would say the displacement would be 4.67 meters at an angle of 157 degrees. So our full answer for displacement includes direction in the form of an angle and displacement.
But which angle did we try to figure out?
It's always from positive x-axis to your vector. And so it's this one right here.
Okay.
So we found this angle using an inverse tangent, but we wanted really this angle, so we subtracted 180 to get the angle we really wanted. I know it's a long process, but once you get the hang of this, it goes pretty fast. And this one, I think, it depends on the situation, but generally, you're gonna want to use this set of log cosines for cases like that, where they give you two journeys, like you turn at a certain angle and they give you a distance. This probably is the best way to go about it. You make less mistakes this way in that situation. Any questions about that? Okay, so work today on page 125. Do 5 and 7. And then go on to do 9 through 16. So 5, 7, 9 through 16. Write down the board for you all.
What, 5 through 7 or 5?
5 and 7, yeah, just don't do 6. So do 5, 7, and then 9 through 16. And that's on page 125.